our So tonight we'll be talking about WeCloudData's data science bootcamp curriculum. We'll briefly talk about generative AI, how it can help you become a more efficient data scientist, and we'll cover the job aspects of it as well. So let's get started. First of all, I would like to introduce to everyone the bootcamp options with WeCloudData. If you're currently looking for a bootcamp or looking for a career change, and then I'll talk about data science curriculum, which includes generative AI. So if you're interested in getting started with data science, WeCloudData has three different options. We have part-time and full-time training boot camps that includes portfolio projects. Portfolio projects is very important. These are sometimes also called capstone projects. It showcase your overall skill set to work on projects and do problem solving. But WeCloudData's data science bootcamp also comes with what we call the real client project. The real client projects put you in a real environment to work on real life challenges, and you work with our consulting clients directly. That allows you to fill the experience gap. And also we provide 6 months of career mentorship, and these are one-on-one based. And you have the flexibility to book meetings with a data scientist to help you with resume and job support. So when it comes to the bootcamp, we start the bootcamp by introducing the data science fundamental. Recently, we also added the generative AI elements into the bootcamp. We also have a standalone generative AI introduction course, which is also given to the data science bootcamp student for free. And that alone is a 30-hour course that covers no-code AI, generative AI introduction, prompt engineering, everything about how to leverage generative AI to become more efficient, whether it's at coding or becoming more efficient at communication. And then after the data fundamental course, we start to teach students data science skills, which includes data visualization, data preparation, data exploration, and of course that covers things such as Python pandas and statistics. And then we move on to machine learning. We also cover big data. I think one thing that's very unique about WeCloudData's data science bootcamp is that we emphasize on big data and cloud. So you're not just learning how to train machine learning models in a Jupyter Notebook environment on your laptop or using Google Colab. We actually teach students to how to scale data science using Apache Spark running on Databricks. Student will also learn AWS, how to work with EC2 instances, and also cloud storage such as Amazon S3, writing Lambda functions. And overall, I think our alumni and graduates will become a well-rounded data scientist. And of course, right now the job market is really tough. I think a majority of the boot camps out there, the success rate, or if you're shopping around, I think you should be aware that most of the boot camps in the past 2 years, the job placement rate hasn't been really shiny. We used to have 90%, now it dropped to 70%. But based on our research, we know that some of other boot camps placement may have dropped down to 10%, 20%, 30%. But overall, the market is just not good. It doesn't really mean that boot camp is not a good option anymore, because even if you graduate from a 4-year computer science background, it doesn't, program, it doesn't mean you're going to get a job. But I think what we can do is just get ourselves prepared, right? The bootcamp only teach you, or university only teach you the hard skills. And then what sets WeCloudData apart is the experience building part. So we do have the real client projects. I can introduce the real client project to you, at the end if you're interested. And then we also provide one-on-one career mentoring. So that really helps you save time and be more effective in interviews. So that's the boot camp. But if you already graduated from a boot camp and you couldn't find a job, WeCloudData also has some program for you. For example, the real client project. So that's assuming that you already have data science, analytics or data engineering skills. So you will not be joining any live training anymore. You need to be screened. We make sure that you have the right skill sets to work on real projects. Otherwise, you will not be admitted into the program. And once you're in the program, you will be put through self-paced learning. But that happens in parallel. So some of these self-paced training materials could be pre-recorded. It could be things that we learned from the past real client projects. There will be project management training as well, and you'll be working with our dedicated project managers on projects. Each student will be working on 2 to 3 real client projects over the duration of 6 months. So it could be one big project over 6 months with one client, but some students may prefer to work with 2 to 3 different, smaller clients on smaller scope projects, but they get to add more projects, under their experience section of the resume. So this is totally up to the students and also depends on the availability of projects, of course. And then the one-on-one career mentorship is also optional. A lot of students would like to just go with real client project because that's the only thing that's missing from their resume after they've done boot camps or got certifications from online courses or graduate from a master's program. So if you're in this category, definitely come and talk to us. I think I think we have ways to help you become successful in the job market. We also recently introduced a self-paced data science program. So the self-paced course is not really Coursera course. And of course, we recorded the entire boot camp. It's really mainly designed for someone who just cannot join a full-time program. They want the flexibility, right? So it's self-paced learning. But I think for anyone to be successful in a self-paced program, you need to be extremely self-motivated, right? But majority of the people are not like that because it's pretty lonely and long journey. So this is a self-paced program, but you not only get access to all the content, you can finish, everything within a month, but usually it's not possible. But if you're really dedicated, you can go through materials as quickly as you can, or you can take longer time to complete them. You will be able to work on capstone projects, but most importantly, you're going to get, live Slack support, and also on a weekly basis, you will be talking with your learning mentor. The mentors can play different roles. It could be different mentors. You can have your TA mentor, which is mainly providing support on exercises and projects. You can have project mentor, but it could be career mentor as well. We do understand that sometimes when you go through a boot camp, career support kicks off at the end. But in a self-paced program, if you would like to get started with resume, no problem. Go talk to your mentor. But the mentor is not here just to wait for you to book meetings with them. There is a strict curriculum that you need to follow. So even if you don't reach out to us, we'll need to push you to make sure that you can actually deliver, basically complete the program. Otherwise, then you might as well just take an online course from Udemy or Coursera, and the cost will be pretty much free. That's what the program is about. And on a weekly basis, we also have the live component, and we sometimes do workshops as well. So you will be joining some sort of like 2-day weekend-based or even 5-day based, extensive or immersive, live sessions just to review all the knowledge we have. So this is the self-paced program, and the cost will be quite a bit lower than the live bootcamp. If that's something you're looking for, come and talk to us. So this is a typical bootcamp journey, right? You finish 12 weeks of training, and then there's some demo day, demo week, and then you receive career support. With WeCloudData, if you're joining our full-time bootcamp, which just started actually, so it's 3 months training, but you need to complete 2 to 3 capstone projects during the bootcamp. And then after the bootcamp, there will be 6 months of experience building period where students will join career workshops. These are group sessions, but then you also have one-on-one career mentoring for 6 months, and the mentors will be helping you getting jobs. And as I said at the very beginning, it's a really tough job market with so many tech job cuts. So you're not expecting 85%, 90%, 95% placement rate anymore. But I think fortunately WeCloudData, because of the way we create and set up the program, plus the real client projects, we're still able to achieve 70%, which is really, really good. I think we're definitely one of the top boot camps in terms of how we help students become successful in a tough job market. And this is the part-time program. The only difference here is that if you have a full-time job and then joining a part-time program will make a lot more sense. So the duration will be longer. It will be 24 weeks, and then you will, basically attend live sessions weekday evenings or during the weekend as well, and everything else stays the same. Now, I'm not exaggerating when I say we have 70% placement rate, because even though I don't have the number from Education Ministry, but I do have the number from 2021, which is the most up-to-date release of official numbers. And I summarized that, for different boot camps. So I'm not going to name other boot camps, but WeCloudData back in 2021, which the job market was actually really good. If you look at the employment rate, it's 90.9%. But it's more important to look at the employment in data field, which means students graduate, they attended the data science bootcamp, and they get a data job. It's not like any type of job at a data science or data company. It's the data job. So we still maintain that at 90.9%. So our students rarely get a job that's not data related. I think that's mainly because of the real client project experience that we allow the students to add to their resume. If you look at the next bootcamp in terms of next best bootcamp in terms of the employment rate, it drops to 84%. It's still very decent. But if you look at the employment in data category or in the data field, the in-field placement rate, it dropped to 68%. But the third on the list drops below 50%. That tells you how big of a difference it could be between different boot camps. And as I said, in last year, the placement rate dropped to about 70%. So that's where we are right now. All right. So now I would like to introduce the bootcamp curriculum. Even if you're not interested in boot camps, I think the curriculum will interest you, because even if you just follow this bootcamp curriculum and then you go find online learning resources, this is still going to be very helpful. So let me go through the details. As I said, the prerequisite will be data fundamentals and basic generative AI skills and knowledge. As a data fundamental component, SQL is really important. I think as a data scientist, you're not always going to build machine learning models or AI models. Majority of the time is actually spent on data pre-processing, data extraction, data visualization, exploration. In a real-life environment, you're most likely to use SQL instead of Python running on your laptop, right? Because most of the big data, production data is actually stored, or operational data are stored in databases. So you need to know how to speak the database language, right? Using SQL to interact with databases, write queries, and even do data analysis to generate insight. In Tableau and Power BI, we have self-paced, material. So if you do basic data analysis, it's always good to be able to build some pivot tables and visualizations, or even Tableau dashboard. So that's the SQL component. And also we covered the very basics of Python. This is not a course to help you become a Python developer. So we mainly focus on Python programming basics, because there are a lot of career switchers joining these type of programs. So you do need to have a primer on Python and basic programming. So we cover Python fundamentals, basics of functions and modules. We also have self-paced materials on advanced topics such as object-oriented programming, data structures. But as a fundamental course, we like to focus on how to use Python to do data manipulation. So we'll introduce Pandas data frame and also the basics of data collection. Data collection is very important. Data scientists don't always just build machine learning model. And sometimes when you don't have the right data you need, you may need to read data, write some Python code to read data or collect data from a third-party data APIs, or even need to do web scraping. If you're building generative AI models or fine-tuning GPT-4 models, you will need to prepare the data, and you need to massage the data into the right format so it can be consumed by GPT-4 large language model. So the basic data collection, data manipulation skill is very important. We also cover a little bit data visualization. This is not a BI or data analytics program. So the Tableau component is mainly self-paced, and in the data science bootcamp, We do have one project where the student will actually need to build dashboard, but that's more like data science analytics project. So, but we will not this training program, because it's data science, is not going to teach you Tableau in detail. But we do have self-paced material. Generative AI is something we recently added to the curriculum. We're very excited about this. So we will offer generative AI introduction, prompt design, and prompt engineering. We cover a lot of generative AI use cases and also cover the ethics of AI and responsible usage of generative AI. We also cover AI automation. There are tools such as Zapier, Make, that allows you to automate AI workflow. For example, if you're writing, you would like to automate email responses, or you do a lot of research, read a lot of papers, and then you can summarize, create a workflow to summarize a paper, and then send or write the summary to a Google Sheet. You can automate the end-to-end process, which will help you save a lot of time. So this is the data fundamental course. It's actually pretty loaded for someone who's completely new to tech, but this will prepare you really well for the data science bootcamp. We also introduced no-code ML and no-code AI in the actual generative AI introduction course. As I said, this course is offered for free to our data science bootcamp students. So we'll introduce machine learning for beginners without coding knowledge, and then this component focuses on no-code AI. We'll cover KNIME as well as Amazon SageMaker Canvas, and H2O is also offered as self-paced, and we have a lot of labs on that as well. That gives you a primer on machine learning, and then of course in the actual bootcamp, we'll dive a lot deeper into the technical aspects of it. So what is generative AI? Artificial intelligence is very broad, right? You can have many different types of applications, and machine learning is part of AI. And specifically, we use machine learning to automate tasks. We can use it for, doing classification. We use it for supervised learning. We can use it to, to do regression analysis as well. But when we have lots of data, we're not going to do any kind of inference manually, right? That's where we use machine learning to automate the decision making. And there are a whole family of machine learning algorithms that you need to learn in the course. But as as the fields start to evolve, I think you just need to focus on some of the key machine learning algorithms. A lot of other algorithms are actually becoming pretty obsolete and outdated. But it's more important to understand the end-to-end workflow and how to build machine learning models. It's not just about the algorithms, and the data collection, data preparation, feature engineering is also very important, as well as model interpretation. Now, I actually believe that part of the machine learning pipeline can actually be automated. So I don't think the future of data science is just focusing on building machine learning models. It's more about how to leverage these AI tools to become more efficient at business decision making, and we can do this at a faster speed, and also do that at a bigger scale. So I think that's the philosophy we apply at teaching. So we tend to be more practical instead of being very theoretical. Deep learning is a specific branch of machine learning. But in particular, it focuses on neural networks, which is a specific techniques that people use to train machine learning models. And generative AI is part of deep learning, because most of the generative AI models are based on neural networks. It could be computer vision models, generative image models, vision models. But of course, large language model, LLM, is part of generative AI. And it has generated a lot of buzz in the last year. So how do we use generative AI? When we use generative AI, there are different purposes, and people coming from different backgrounds may use it in different ways, right? But I think we need to learn, generative AI and techniques such as prompt engineering, right? It helps you become more efficient, whether you're a data scientist or not. Even if you're working marketing and sales, I think we've seen a lot of potential in using generative AI to automate things, right? As a data scientist, though, we can use generative AI to help with machine learning tasks. I think in the past, we wanted to train, get a lot of text data and train sentiment analysis models. And then getting the right label is actually a very manual task. So that's not very scalable. And most of the sentiment models are actually not that accurate in terms of accuracy. But with generative AI now, we can even use, tools like OpenAI's ChatGPT or GPT-4 to label the data for you. And then you can train, task-specific models, right? So it has a lot of benefits, okay? We can design data science products powered by generative AI as well. For example, we can build recommendation systems powered by generative AI technologies. So that's pretty cool. I think most of us will be the users of generative AI. But if you would like to go deeper, for example, you want to become a data scientist that specializes in generative AI, or you want to work in machine learning engineering, LLM engineering, then you will need to, go deeper and learn more about how large language models are trained, fine-tuned, right? And also learn how to build LLM-powered applications such as, RAG and enterprise search, semantic search, and things like that. So this field is evolving really fast, but that's what makes it very exciting. Okay. So what is generative AI? It usually takes input and give you some sort of output. And this is actually very similar to machine learning. With machine learning, you need some sort of structured, right, data input, and you do feature engineering and then use machine learning algorithms to learn from the data, and then it allows you to perform tasks such as classification, regression. Generative AI usually takes, an image, audio, right, or text prompt as input. And in this example, my prompt is, draw a chihuahua that has yellow fur, cyberpunk style. But this is just like, how we prompt, how we do prompt engineering, and we feed that prompt into a generative AI or a large language model, and it generates the image, right? You can use Midjourney, or you can use, DALL-E. I think in this case, I generated this picture using DALL-E 3. Okay, but we can do image to text generation as well. We can do text to text, image to image. There are a lot of different, applications of generative AI. Okay. If we're talking about text to text or text to image, and that's powered by large language models. So what is large language model? It's typically, autoregressive model, but this is very technical definition. Essentially it predicts the next word, right? But how we achieve that, there are a lot of secret sauce, and people do that in different ways, because I think solving the scalability challenge is real. So, but essentially, a large language model, most of the popular large language models used out there, such as ChatGPT, Bard, they are all decoder-only models, and essentially they're just autoregressive models that's predicting the next word. So in this case, let's say the step one is my name is, and then based on the probability, it's going to predict the next word. So let's say it predicts ChatGPT. And then we use, in step two, then we use my name is ChatGPT. The ChatGPT word was a completion in the previous step, right? Or the prediction in the previous step. And now you have one more word in the context, which is my name is ChatGPT. And then it's going to just keep going and predicting the next word. In this case, the next token is a comma, right? And after the comma, and it will say, pleased to assist you, right? So, whether how the model spits out this sentence really depends on the training data. And that's why for a large language model to be successful and useful, it needs to be trained on a huge amount of data. And that's one of the challenges with the computing, right? It requires a lot of money to train these models. But in a nutshell, it just predicts the next word, and there are many different ways to do the ranking. And I'll skip all of these technical details. Okay. Now, after you understand like what a large language model can do, in this data fundamental, or in our generative AI training course, we also introduce AI automation, because I think everyone knows how to work with ChatGPT, but it doesn't necessarily, and it's very helpful, but in a work environment, it doesn't necessarily make you that efficient. What if you need to do translation on 1,000, documents? You can't possibly just like do this like manual copy and paste into ChatGPT and wait for the answers to be, created, and then you save that back to your document or a Google Sheet somewhere. You want this to be automated. And that's why I think AI automation is the real deal here. We not only need to know how to do prompt design, we also need to know how to work with like workflow automation tool to actually automate something. And this is going to significantly increase the productivity. I think even if you don't want to become a data scientist, this is something you need to learn. There are many no-code tools out there. I'm sort of just mixing the no-code ML tools and AI automation tool in the same table here. But first, there's some no-code ML and no-code AI tools, such as Amazon SageMaker. It's powered by AWS and it's pay-as-you-go. It's pretty decent tool. It allows you to interact with not only the classical machine learning algorithms, but also large language models, computer vision models. You can use it to do a lot of things, but it's quite expensive, to be honest. There's an open source, version tool called H2O.ai, and it has a GUI-based tool called H2O Flow. As long as you can have that set up on your, computer or laptop, you will be able to sort of build machine learning model pretty easily, and you don't need to write code. But of course, you can still use Python and R to interact with H2O. But H2O Flow is designed for those people who don't want to write code and still want to build machine learning models. And there's also, the OpenAI that allows you to do generative AI and, Q&As, text summarization, a lot of use cases. Another no-code machine learning tool I would like to recommend is Nime. It's open source, so you don't see many open source options out there. But this one is really cool. It's free, but it also has the enterprise version. It's no-code ML. You can basically click and drag to build a workflow, just like how we use Excel. It's very cool. And it integrates with generative AI tools and also some Python packages such as scikit-learn, which makes it actually very useful. Now, when it comes to AI automation or workflow automation, I think many of you may have known Zapier already. Zapier is a SaaS tool that allows you to automate workflow. You can pretty much automate anything, and it has connectors or integration with thousands of applications, which is really cool. It's not free, but I see a lot of companies, if you're okay with your data, somehow get sent to the Zapier server. If that's the data you send to Zapier is not that sensitive, I think Zapier could be a really good option. But if your company is a Microsoft shop running on Azure, then Power Automate is a really good option as well. It's kind of similar to Zapier, but it offers some other benefit as well. And of course, ideally your company use Microsoft solution. Okay. All right. So what can we do with AI automation? We've been providing the generative AI training for 4 cohorts in different regions. Some of our clients are based in UAE and Saudi Arabia. So we've tested this course 4 times, and we've seen some really exciting mini capstone projects built by the students. Some of the ideas include, I see that video transcriptions and translation, there's a big demand. A lot of students would like to, our enterprise students would like to do email automation. Some students want to, and just like as a, like a daily reminder, they would like to use ChatGPT or OpenAI and Zapier to read their emails and find interesting stuff and generate or create reminders and put something important in the calendars, updating social media automatically, summarizing meetings, even creating reports and summarizing, in like research papers and things like that. Very interesting use cases. There's some ad hoc use of a ChatGPT, which is not related to automation, but again, I think ChatGPT is super powerful. Now you have more options such as Google Gemini. And when it comes to no-code AI or no-code ML, we've seen students in the aerospace field analyzing data of engine and use that to predict engine failure. And there are people from material science PhDs using no-code AI tool to do really interesting machine learning projects, actually using no-code tool. And there's some sort of 3D corridor data analysis related to flying cars. And the students eventually use Python to do more sophisticated version of the model, but their first draft was actually created using Amazon SageMaker, which is really cool. So these are some of the things you will learn in the generative AI course. All right, so how do we get started with generative AI? We're still talking about the data fundamentals and AI fundamentals. So first of all, I think you need to learn, prompting, the basic prompt design, right? So working with ChatGPT, Google Gemini, or even Bing on a regular basis. I think the more you use it, the more experienced or the better you'll become at prompt engineering. When it comes to AI automation, I think it can definitely help you improve the productivity and the goal here is to, let's say, become a more efficient data professional. ChatGPT has data analysis capability already, even though it's not going to replace the data analyst. I don't believe it's going to replace the data analyst, because if the data analyst is only doing very basic Excel work, then yeah, that should be automated, right? But I think the real value of data scientists and data analysts is really not just the data analysis or coding part, because the coding part is not that challenging compared to software engineering. But discovering data insight and actually, creating something that's insightful and useful for the business, that is more important, right? But you're, relying on these AI automation tool to help you become more efficient. So I think that's actually really a good thing. And then if you want to go deeper to become some to be able to fine tune and even train generative AI models, then you'll definitely to have the data science and machine learning fundamental skills. So you need to go through a learning path to learn how to do data analysis, how to train machine learning models, the basics, right? When you work with a large language model, maybe you can use Python to interact with it, right? Instead of just directly working with ChatGPT. And then you'll need basic AI skill set, right? Deep learning, working with PyTorch or maybe TensorFlow, know how to interact with large language models through Hugging Face, and also understand the fundamentals of transformers, which is the algorithm behind most of the large language models. Those fundamentals are also very important. And then after that, I think you need to learn fine tuning and also how to build LLM-driven applications. We offer the deep dive in our large language model course and machine learning engineering program. But this is just a learning path if you'd like to get started with generative AI. There's some resources I would like to recommend. So WeCloudData has the GenAI introduction course. It's included in the data science bootcamp, but we also have a LLM specialization course. We cover NLP as well. So if you're interested, you can come and talk to us. There's some really great online resources. Deeplearning.ai has AI introduction course, generative AI. They have a lot of great content. Databricks has a free large language modeling course. Coursera has a ton of great resources, of course. And there's a company called AI Academy. I found them through TikTok, but they had one pretty decent prompt engineering course. It's not very expensive, but if you're interested, you can check them out. And of course, I also personally rely on YouTube to learn a lot of new things, because you can get access to conference video recordings, and there's some free courses as well. All right, so that's generative AI resource. Next, I would like to move on to the next component in the data science bootcamp curriculum, which is data science. This is the curriculum for data science course in the bootcamp. First, we start with data collection. As I said, I firmly and strongly believe that data scientists need to have data collection skills. It means collecting data from, through some sort of Python APIs, even do web scraping. Imagine your team wants to build a generative AI application, and you want to fine tune large language models. And oftentimes the biggest challenge is actually just don't have the right data to do fine tuning. And you may actually need to do web scraping. Recently, in one of the real client projects, our data science bootcamp and data engineering bootcamp students are actually helping a startup to do a lot of web scraping and data collection, because they want to build, first of all, they want to build their own, applications. But the next iteration would be introducing large language model driven customer service bot, and also fine-tuning large language models. So they want to build a knowledge base. They've collected data from millions of web pages, and we help them scale that solution. But before you even get to the point where you can train generative AI models, you need to collect data, right? So web scraping is actually a very important skill to have. And it also helps a learner or someone who's, at the beginner level to quickly improve the programming skills. After the data collection, I think students will need to learn how to work with the data and how to analyze the data. So we introduced Pandas data frame. I think it's taught in any data science curriculum. I think it's super important. And also we covered data munging and preparation with Pandas. After data manipulation, I think, you will need to start exploring data, right? So visualization, exploring data using Python, doing EDA. EDA is short for exploratory data analysis. You need to, before you even build any machine learning models, I think you need to have the basic data analytics skills, which means if you have the data access to the data and the business team asks you a question, you need to be able to use SQL or Python to answer those business questions. That requires data munging skills, right? And if you're going to do statistical analysis, and of course, you need to know how to do data preparation. And then we do cover regression analysis and basics of statistics and linear algebra in the data science course. And then other than just the basics technical skill set, we also I think differentiate ourselves by offering real life data sets. So some of the data sets students work with are actually real life data sets, either collected through our own applications or data problems we have worked on in the past with our clients, and we get the permission from the client to redact some data and use that for training purpose. So it's very much real life based. And then in the data science part of the curriculum, we also introduce use cases such as product analytics and digital analytics. And then we also add generative AI capable, like knowledge points in this curriculum. So after the student have learned Pandas data frame, we'll also cover OpenAI and how to interact with ChatGPT or GPT-4 using Python instead of using the UI. And then we also introduced Pandas AI. Next, we move on to machine learning. I think a lot of students are excited about machine learning because of the potential and the wide array of applications. So in terms of machine learning, we will give you an introduction. We always like to begin by introducing real life use cases. So we'll introduce you to machine learning use cases. Introduce the basic APIs such as scikit-learn, but math will definitely be covered. So linear algebra, basics of calculus and statistics will be covered. And also, of course, we cover optimization methods, which will be useful for the deep learning components later. In terms of the basic algorithms and workflow, we cover regression analysis, right? Linear regression, classification, decision trees. These are the really basic algorithms that you need to know. And through this process, I think you need to sort of just gain more intuition about the process and how we evaluate models, right? How do we do model evaluation, validation? And then we'll start to teach, feature preparation and feature selection, which are really important, part of the machine learning pipeline. And after that, we move on to more advanced algorithms such as, ensemble models, parameter tuning, how to build ML pipelines and model interpretation. And then after that, we introduce unsupervised learning. We cover, clustering, dimension reduction, as well as anomaly detection, which is widely used in industry. When it comes to deep learning, we cover neural networks, PyTorch. We'll cover the basics of image classification and also natural language processing, such as text pre-processing, embeddings, topic models, and text classification. This is not a course that's going to turn you into deep learning expert or machine learning engineer. It's still focused on data science, but you will learn enough deep learning so that later on when you work on real client project, you can quickly do research and start to pick up, deep learning and other NLP and computer vision use cases later without attending another boot camp. So I think the whole point of joining a boot camp is to learn something really quickly, but also at the same time, develop your skills, a skill set to learn anything, right? So, to learn anything quickly. So I think the problem-solving skills and the learning ability is what you're gonna the skill sets you're gonna develop in the boot camp. When it comes to the generative AI, as I said, we introduce generative AI in every part of the curriculum. So we cover LLM introduction, and we also introduce Scikit LLM, which is LLM, basically created for scikit-learn users. It's pretty straightforward to use, but I think the modern data scientists will definitely need to know how to work with large language models. Students also get to work on work with some of the real life data sets, such as mixed panel data. There's some data that we internally use, and we redact the sensitive information and let the student work with those data for training their machine learning models. There are sales data, such as HubSpot, Indeed, job classification data, and even Web3 data. That was a data set that was shared by one of the clients in the past, and very interesting Web3 data set. We also cover a lot of industry use cases, and we have guest lectures. So you get to interact with experts and domain experts from the industry. A lot of times your career mentors, they actually do specialize in certain aspects of data science, so you can pick their brain as well. So that's the machine learning. As you can see, this is probably the heaviest component of the data science bootcamp. But as I said at the very beginning, WeCloudData is also pretty proud of the big data part of the curriculum. We spent a lot of effort designing this part of the curriculum. So we introduce students to big data, distributed system. We introduced the basic concepts of MapReduce. Not only that, we also teach students how to scale pandas. Pandas is not very scalable, right? It's memory bound. So if you don't have a lot of memory, or the data set you process is much bigger than the memory size, then you will not be able to use pandas. So there are many other tools that can allow you to scale pandas, and they have similar APIs. So we introduce this kind of tools, and then students will get introduced to Amazon Web Services. We'll introduce the basics of cloud computing. We cover EC2, which is compute, and S3, storage. So you will know how to set up EC2 instances and install software yourself, and then you will know how to use Python to interact with the object store, such as S3 in Amazon Web Services. And you need this kind of knowledge and skill set in order to complete the project. And then we move on to big data processing with Apache Spark. We'll introduce students to Spark SQL, Spark Data Frame. And then most importantly, since this is a data science program, you will learn how to scale machine learning models using Spark. And here we mainly focus on data parallel problem. And for model parallel problem, you probably need to rely on PyTorch and GPU instances. But Spark is really well known for data parallel processing. When you are dealing with hundreds of millions of records or even more, it doesn't work on Python. So you have to use a distributed framework, and Spark is for that purpose. But how do we build machine learning models using Spark? Right? So that's just a different API you need to learn. So we cover this in the bootcamp, and students will need to complete a big data project. For example, like sentiment analysis, which is also real-time based. So we cover how, data ingestion in real time using AWS Kinesis, and then use Spark to do machine learning, train your models, and then you can deploy the model for prediction. We also introduce MLOps. Again, this is not an MLOps course. We do have LLM Ops and Machine Learning Operations course in the Machine Learning Engineering program. But here we focus on SageMaker, so the student will learn the basics of model deployment, so you can build something end-to-end. Okay. Some of the data sets student will be dealing with, data sets coming from healthcare, digital advertisement, product analytics. So the size of the data is much, much bigger than some of the data sets you work with in the machine learning course. And we also cover some industry use cases, such as fraud detection, ad tech applications, such as click-through rate prediction, recommender systems. Okay. So after you complete the bootcamp, I think you're able to add keywords, right, and skill sets to your resume. Like you can add programming skills, analytics skills, machine learning, and big data, or maybe cloud. But that's not enough for you to be successful in the job market, because I think anyone can add keywords to their resume, right? What the employers care more about is your actual experience. So that's what I'm going to talk about next, which is the data science job skills. In the bootcamp, in all boot camps, actually, right, or any online training, what you're gaining from the program is the hard skills. But that's not enough for you to, succeed in the job market. So let's talk about the job skills. What are some of the skills that can help you actually get a job, or at least stand out so you can get more interviews, right? So first of all, of course, you need to have hard skills, right? And you learn that from Udemy, Coursera. You go to, universities, you attend boot camps, you do Kaggle competitions, and then you build up your skill set. Right? These are hard skills. You spend months and months on these, right? Sometimes even years. But hard skills doesn't mean you're going to get a job, right? And the correlation is actually not that high. So let's take a look at the job skills you need. It all needs to be based on how data science work in real life, right? So let's take a look at the life cycle of a data science project. Usually the need is driven by the business or product team, right? So you need to do project scoping. You need to understand what the data science team or this data science project needs to accomplish. You need to scope out the project, right? And communication and people skill also very important, okay? And then after that, you need to collect data, right? You need the right data to support any kind of data science work. And then you move on to data preparation, modeling, or machine learning. And then either you deploy the model in production, or you share the insights and whatever you learned with the business, right? That's the general workflow. But let's dive a little bit deeper into this. When you scope out a project, right, you need to understand how to collect requirements, right? You need to know how to have meetings with the stakeholders, whether it's a director or VP, or a manager from the marketing team or the product manager. You need to understand the requirements, and you need to know how to respond to people's questions, right? Sometimes you just have to say no. Feasibility analysis is very important, right? You're not always going to complete a data science project with a positive return on investment. A lot of times data science projects actually fail. So that is experience, right? Should you even move ahead with the project? And how do you communicate the pros and cons of certain approaches to the team, right? Cross-functional or cross-team communication skill, very important. The data scientists need to be comfortable not only with communicating with the business side, but also IT team. You need to ask for data. You need to communicate with maybe the software engineers and data analyst, data engineer as well, right? You need to be comfortable writing technical proposal, or even not the full proposal yourself, but at least PowerPoint, and be able to confidently present ideas to the business team, right? And sometimes you sort of work as a data science architect, because you need to build end-to-end workflow, and then you need to wear your data architect hat. Relationship building is also very important. A lot of times you can't, the data science projects, you can't push that through because you just don't have the right sponsor, right? Or sometimes you cannot get buy-in from executive teams, and that is very important as well, okay? Now, after everything is scoped out, you have a clear goal and target, right? You would like to go ahead and implement your data science solution for the company. And the first question that you're going to ask is, do I have the data, right? So, well, first of all, do you even have the data infrastructure? I've worked at a startup where I'm the first data scientist, and the only person I'm reporting to or I work with is the head of data, right? So there are only 2 people on the team supporting a company of 60 people. The company has awesome, software, application, 300 million users, right? Massive amounts of data, but there's no data infrastructure. So I'll have to help the company build everything from scratch. That means I thought I joined a company as a data scientist to build machine learning models. But in this first 6 months, right, I was actually just building data warehouses, setting up data pipelines, learning how to work with cloud, learning how to set up databases in data warehouse. Fortunately, Amazon Web Services or any cloud vendors will make this effort easy. But without the proper data infrastructure, you cannot move ahead with data science and data engineering, right? Data governance is really important. You don't need to be an expert, but you do need to know what data you can use, what data you cannot use, right? Data modeling. But this really depends on the company and team you will be joining, right? If you join a large company where they have established data science practice, then you don't need to worry too much about data modeling, because the data model is most likely done, and you will just need to understand the data model so you know how to write queries to extract data. But if you're building something new for a startup, then you do need to understand data modeling, even as a data scientist, because you're going to contribute your ideas and tell the data engineer how you would like to use the data, right? So you will be part of the data modeling effort, and of course, data collection sometimes, and data annotation. These are not always data scientists' job, but you do need to know who to talk to get the data, right? But a lot of times you need to annotate the data. It doesn't mean the data engineers will always have the time to do that for you, and they may not be specialized in doing this. So you need to understand how to collect labels as well. Data annotation, you can do that manually, but what if you want to scale that, right? So there are tools that you can work with, but you might need to work with, for example, Amazon Mechanical Turk or SageMaker API to automate the data collection and data annotation process as well. Data pipeline is also important because you don't always want to do things manually, right? So these are not necessarily the data scientist's responsibility, but you do need to understand that these are important, success factors. Without these, you cannot make a data science project successful. And reporting and analytics are also very important. I remember when I joined that company, the first 6 months after we have built a basic version of like MVP of a data warehouse, and people start to ask all kinds of questions. And everyone was data hungry and information hungry. They would like to know all kinds of metrics. And finally, we have a data warehouse. So you sort of work as a data analyst instead of data science, until one day that everyone gets the report they need, and we have some basic dashboard in place, right? And then you have the time to actually start doing machine learning, because at that time, people will start to ask smart questions. You sort of educate them start to build the data culture for the company, and people will start to have the need for more advanced analytics, right? So having reporting skill set is also very important, and that's why you see a lot of data scientists also doing data analytics work. It's totally normal. It's not always going to be about machine learning. Okay. All right. After you figure out data, I think the next part is just modeling or machine learning. Then you need to understand how to prepare a data set for machine learning model training, feature engineering, predictive modeling or machine learning, right? And also model selection, testing, validation, and going through many iterations. So I think that's the hard skills you already have, right? When you go through a training boot camp. But as you can see, modeling is usually just one step in the whole process, right? It's not everything. When it comes to insight, right, you need to be able to explain your models to the business. I remember when I used to work for a large telecommunication company. I work on the cable side. I built a lot of machine learning models, especially like churn models. The business usually don't really care about what algorithms are used. They only care about like the interpretation. Like they know the model is pretty accurate, but they want to understand how to use it. Because they even if you have a model that can predict which customers are going to leave or cancel their subscription, they still wouldn't understand how to communicate with the customer. Like what can help them to retain a customer, right? So they want to know more about the customers, and you have to do profilings, but they also want to know the top drivers, like the most important variables, right? And they'll ask you all kinds of questions, under the assumption that, well, this is causal relationship. And oftentimes you have to explain to them that this is actually correlation, right? Association, not necessarily causation. So a little bit of education will need to be done, but you absolutely need to nail the communication part in order to build credibility, so people are even willing to use the model. If they don't understand the model, they're not comfortable using it, for their business. Analytics is important in business communication, and also relationship and trust building is really important. If the business cannot trust your model, even if your model is 99% accurate, they will still not be comfortable using it, right? So that's the insight. And a lot of data scientists actually work on this part. It's not always about deploying models in production, right? So, but if there is a need, right, to turn the data science work into some sort of data product and you would like to deploy that in production, then we're talking about ML pipelines, right? Building the feature store and how to persist the model and generate, model endpoint and do model serving. These are related to machine learning engineering. Some data scientists get to work on that as long as you have the skill sets, right? But it falls more under, machine learning engineering. So I think consider this as an upskilling opportunity for data scientists. I think if you already work as a data scientist, then definitely learn more about, how to productionize your machine learning models. And also test and learn. So when the model is deployed in production, you need to understand how to do monitoring, A/B testing, right? Test and learn, and also reporting analytics. So that's how it works. This is one type of machine learning project, right? And what you do as a data scientist in real life might, just be very specific. You might focus on data model training, right, for 3 months. And then you get put on a different project where you actually spend more time on data analytics or data collection, data engineering, right? And if you work for a startup or consulting company, most likely you'll be involved in the initial stage, which is project scoping, right? And maybe through multiple projects, you'll learn how things work end to end, right? You'll be fortunate enough to actually just work on something end to end at the very early stage of a data science career. And that's definitely the opportunity we'd like to go after, okay? So what's the difference between junior data scientist and senior data scientist, right, when it comes to job skills? I think first few months on the job as a junior data scientist, the task, the scope of the work will be narrow, right? You get to focus on something very specific. In the first week or first 2 weeks, you might actually just be reading all the documentation or reading other people's code. And you need to spend time understanding the data models, so you know how to extract data and prepare data, right? That's a great opportunity for you to improve SQL and Python skills because you've learned all of these in the boot camps, but you need to know how to put them to work. And that will probably be the first time you're dealing with massive amounts of data. Instead of working with 3 data sets, you'll be working with a data warehouse that have 500 tables, right? That could be overwhelming. You'll be reviewing existing code base, and you'll be doing a lot of reporting and analytics as well. And even just for yourself to understand the data better, right? You might be reading documentation and also learning the business rules, okay? A senior data scientist will spend more time assessing the client needs, right? Clients' needs, whether it's internal clients or external clients. So they will be more in more meetings, helping the team make more decisions. And they will have the opportunity to oversee end-to-end project implementation, right? They work on more complex tasks, and they may need to deploy models in production and communicate the results directly with the clients and meetings, other teams, right? You might be in the same meeting as a junior data scientist, but it's definitely the senior data scientist that may get the opportunity to present, or the manager of data science team, okay? And you're helping the team to establish best practices as a senior data scientist. All right, so let's talk about the job skills and also technical skills, right? At the bottom here, you see that through online courses or bootcamp training, you're definitely learning the technical skills, okay? And then through the bootcamp or any kind of like college diploma programs, I think they'll ask you to build personal project or capstone project or portfolio project, right? Not many people complete capstone projects, right? Let's assume that you do. WeCloudData can help you set you apart because you work on the real project experience, and you will definitely stand out in the crowd because you'll be put in the experienced category instead of new grads or beginner. So that's what we're striving to achieve through our bootcamp for the students. Okay. And that's pretty much it. A quick introduction to the curriculum. And now I would like to, quickly go through the job support program. I'll explain to you how we actually support the students. So your journey to job offer right, with the bootcamp, and first of all, you go through skill set building, whether it's self-paced program, full-time, part-time bootcamp with WeCloudData. And then after that, you start to build up your experience. Portfolio project is part of it, but real client project is more important, right? And then the student will receive mentoring, whether it's group sessions, one-on-one sessions, and we have job referrals as well. And then that helps you get a job, right? That's a standard process you can follow. But of course, it doesn't mean that you have to have the mentorship or real client project in order to get jobs, right? But this is a typical process our students go through. We also have, as I explained at the very beginning, we have now different options, right? So we try to keep it more flexible for students coming from different background. So for full-time students, they finish the bootcamp first and then work on the real client project and then receive the career mentoring. Career mentoring can happen in parallel as the real client project. But then some student will actually choose to basically, finish the bootcamp first, and then they do the real client project while they receive the career mentoring. So that's another option if you would like to sort of squeeze the timeline. Some student would prefer to wait longer, so they build more experience first. We also have the part-time option, and of course, the only difference for the part-time live bootcamp is that you have a full-time job, so you can't really commit full-time to study. So it will take you 6 months to complete the program, right? But we also have the self-paced bootcamp. The way it works is that you receive one-on-one mentorship, right, on a weekly basis. So as I said, if it's just the content, then you'd rather just go with Coursera or Udemy, right? You need to be extremely self-motivated. But when you get enrolled in the self-paced bootcamp with us, the purple box here means mentoring, right? You receive career mentoring or project mentoring on a weekly basis. So someone will check your progress and make sure you're progressing, right? So that I think that extra bit of push is really going to help you to achieve the target. That's important, right? And at the same time, you have the live sessions with a mentor. You can join the office hours as well and receive support on Slack. But this is created for someone who actually are interested in self-paced learning, right? Of course, if you absolutely just want to sit in a classroom and have instructors teaching to you, then you might as well just join a part-time or full-time bootcamp. Okay. When it comes to career mentoring, for full-time and part-time boot camps, we do have group career sessions. That happens twice a month. So we have career mentors, right, delivering resume interview sessions to the students in private groups. So that can already be very helpful if you would like to get started with resume building at the very beginning. And then after you finish the boot camp, we start the one-on-one mentoring. Now, one-on-one mentoring is really helpful because you get to talk to a mentor. Everything is tailored to you, and then they will support you along the journey. Okay. Some students will have more intensive meetings, have more frequent meetings with the mentor at the very beginning, right after graduation. And then they start to apply for jobs, right? They don't talk to their mentors for a while until they start to have interviews. And then when you start to have interviews, you need support again. That's when you're going to have more frequent meetings with your mentors, right? And then after a couple of sessions, I think you pretty much get a hang of it. And at the end, I think the mentors will be able to help you with salary negotiation, but basically give you the support you need until you land your job. For the self-paced bootcamp, the difference is that you also have the weekly check-in with a mentor. And then if you have difficulties or you have challenges, that one-on-one time is really going to help you and make sure that you stay on the right track, and we push you to complete the bootcamp. And in terms of the content, it's pretty much the same as the live bootcamp. So it really depends on whether you enjoy sitting in a live class or you actually want to finish something faster. Let's say, you have a busy job, and then over the weekend, you actually would like to complete as much as possible, then self-paced learning might actually be a better option for you, okay? All right, when it comes to learning support, all three options, full-time, part-time, self-paced, has Slack support, and the response will be relatively faster. And we also have live teaching assistant or office hours on a weekly basis for self-paced students and part-time. And full-time students don't really have like a weekly thing. It's daily. So on a daily basis, you're going to get support whenever you need, right? So it's live lab and TA office hours on a daily basis, but part-time and self-paced students, it will be weekly. Okay. Group career support. So these workshops, we invite external speakers, someone who work as a data scientist or career coaches to come in and help you with your resume. So they will teach you how to write resume, how to build your LinkedIn profile. Right? So these are group sessions. It will help you with the basics such as how many pages do you need, right? Do you struggle to put relevant experience on your resume? How do you tackle that? If you don't know how to structure the resume, so these are some of the things you will learn in the group sessions, right? But it's not really one-on-one based or tailored to you. So when you work with a one-on-one career mentor, you're going to get dedicated support. They can help you modify your resume, and I think a mentor can help you identify the strength and help you build confidence, and that's really important. Without confidence, I don't think you'll do very well in job interviews. So that's pretty much it. That's how we offer the boot camps. I'm at the end of this presentation. So if you have any questions about, the generative AI learning path, WeCloudData's boot camp, feel free to ask me, and I'll be around to answer your questions. And thank you for joining this session.